Find each quotient and write your answer in Cartesian form. So we have done an example of finding a quotient where we've said the answer is going to be a general a plus bi, and we've written that, we've done a multiplication, we've prepared coefficients. I'm now going to show you how you can do it by utilizing complex conjugates. So if you multiply a complex number by its conjugate, then you get a real answer. So that is going to help us to get the imaginary part off the denominator, and then we can express the answer as an a plus bi. So part A, 4 minus 5i over 7 plus 8i. So we're going to multiply this by the complex conjugate over itself. So the complex conjugate of 7 plus 8i, remember it's only over the complex conjugate of the denominator. The complex conjugate of 7 plus 8i is 7 minus 8i. So we multiply numerator and denominator by 7 minus 8i. Okay, so then we're going to have to do a bit of FOIL work on that. So that is going to be 4 minus 5i, 7 minus 8i, all over 7 plus 8i, 7 minus 8i. So on the top, you're going to have to do we're going to have 4 terms. Once you multiply everything together, you're going to have 4 times 7 is 28. 4 times minus 8 is minus 32, so minus 32i. And you've got minus 5 times 7 is minus 35, so minus 35i. Then you've got minus 5i times minus 8i. Minus times a minus is a plus, so 5 eighths are 40. So you've got plus 40i squared. That's on the top. On the bottom, you've got a difference of 2 squares. So it's 7 squared minus 8i squared. 7 squared minus 8i squared. Okay, so there's a fair bit of work to do. I'm going to say this is 28. Then you've got minus 32 minus 35. So 32 plus 35. 30 plus 30 is 60. 2 plus 5 is 7. That's 67. It's minus, and there's an I. So minus 67i. Then you've got 40i squared. Well, I squared is minus 1. So 40i squared is minus 40. So that's on the top. On the bottom, 7 squared is 49. Then you've got minus 8 squared I squared. So minus 8 squared, 64 I squared. Okay? So I squared is minus 1. So minus 64 I squared is going to be positive 64. So now you're going to have 28 minus 40. So 40 minus 28 is 12, so it's going to be minus 12. Minus 12 minus 67i on the top. On the bottom, you've got 49 plus 64. Okay, so it's going to be a bit messy. So 49 plus 64, well, 40 plus 60 is 100. 9 plus 4 is 13. So you have 113 on the bottom. On the top, minus 12 minus 67i. And you can't do a lot with that other than separate the real and imaginary parts. So you can bring that denominator of minus 13, you can split it over the two of them. So you can say this is minus 12 over 113 minus 67i over 113. So it's not a very satisfying answer, but you've done the division and you've got an a plus bi, you've split it into real part and imaginary part. Right, part B, 4 minus 5i over 8i. Part B, 4 minus 5i over 8i. So here, the denominator is purely imaginary. There's no real parts, but we still need to multiply it by its complex conjugate. So think of that 8i, you could think of it as 0 plus 8i. The complex conjugate of that would be 0 minus 8i. Remember, you just changed the sign of the imaginary part, the bit with the i's. So we're going to multiply this by minus 8i over minus 8i. That's So that might be written as minus 8i times 4 minus 5i over 8i times minus 8i. Okay, so now you have minus 8 times 4 is minus 32, so minus 32i. Then you've got minus 8 times minus 5 is plus 40, and you've got I times I is I squared, and all of that is over 8 times 8 is 64, so minus 64, I times I is I squared. So minus 64 I squared, right? But I'm just going to deal with these I squareds first. So you've got minus 32i, 40i squared is minus 1, 40i squared is minus 40. On the bottom, you've got minus 64i squared, minus 64 times minus 1 is plus 64, so 64. Okay, so you can see there is now no imaginary part in the denominator. Very similar to when you rationalize a cert, there's no radical part in the denominator. You can do quite a lot with this because you have 8 as a common factor, so I'm going to pull it out of the numerator. So I'm going to say that equals 8, and that's 4 8s are 32, so minus 4i minus 5 8s are 40 over, and then 64 is 8 times 8. So if we cancel those two 8s off, 1, we're going to be left with the real part is minus 5 over 8, and then the imaginary part is minus 4i over 8. So it equals minus 5 over 8. Always try and write the real bit first. You've got minus 4i over 8, which can simplify further to minus I over 2, so, or minus a half I, or minus I over 2 would be absolutely fine as well. So that is part B. For part C, 4 minus 5i over 7. Let's see, 4 minus 5i over 7. So just think of that 7 is 7 plus 0i. The complex conjugate of 7 plus 0i would be 7 minus 0i, which is still just 7. So all I have to do with this is just split that 7 up. So I can call this 4 over 7 minus 5i over 7. And that's fine. It's simplified. Those fractions cannot be simplified any further. And I've split it into real plus imaginary. And we don't have to do anything with conjugates if there's no imaginary part.